Hi there, welcome back to the channel. Welcome to the fourth video in the restoration of the Siemens Super G7. This one is the one that's got no body, it's got no cabinet, it's just the chassis, and it's the one I'm not sure how I'm going to handle, maybe an acrylic transparent chassis and all that sort of thing. That's still something I haven't decided, but I wanted to get the FM really working well. That's what I wanted to do. Whether I achieved it or not, stick around, watch the video and decide for yourself. Enjoy. But before I carry on, I want to thank the sponsors of this video, PCBWay. You'll find them at PCBWay.com, and they're the people I go to for all the PCBs that I use in my projects. But of course, they don't just do PCBs, they also do 3D printing, which I've used before to great success. They do CNC machining, sheet metal fabrication, injection molding, and a host of other services that'll take your project right from the beginning all the way to a fully assembled project, if that's what you desire. If you look at the list of products and capabilities, they've got a huge array of services. I'm sure you'll find something for your needs. Look how shiny that is. I have polished the entire aluminium block of the front end, the FM front end, because I've noticed some issues with the FM. I'm not getting the range that I'm supposed to get. There's a section above 100 megahertz, which is really, really weak. So I think what somebody did is they took this thing and extended it to 108 megahertz. Whereas this was actually made to go from 87 or so to 100, probably because they had a station up at the top end they wanted to listen to. I've done that before. My favorite station is at 101.6, so I have extended the range a little bit on some of the radios that I've done, just to pick up that 101.6. But you've got to be careful with this, because when you do that, if you don't align this properly, you drop the sensitivity of practically the whole band. And there are two ways of actually shifting the band. One is you can stretch it. So instead of going from 87 megahertz to 100 megahertz, you can make it go from 87 megahertz to 108 megahertz. So you're sort of spreading it, stretching it. The other way is you can shift it. So instead of going from 87 to 100, you can make it go from, say, 92 to 105 or something like that, right? So that is sort of shifting the range. That second method has probably a lesser effect on the sensitivity if you tune everything properly. But in either case, when you do stretch or shift the band, you do affect the sensitivity, and I think that's what they've done here. So I wanted to go and do an RF alignment of the front end, but I decided, let me focus on the FM, because this radio has been sort of stop-start, and I have not yet decided what I'm going to do with this with regard to a cabinet. I'm still thinking of sort of making everything visible in a transparent acrylic case, but I'm not sure yet. I'm not sure. And just to prepare for that, what I've decided to do is make this thing really shine. This thing doesn't normally need to be this shiny, this polished, but if it's going to be visible, I want it to stand out. So, front end's been cleaned, the socket's been cleaned, the tube's been cleaned, and all the moving parts lubricated. I have not opened this up yet. I think there may be a problem with a little trimmer cap in there, but we'll find out. It's notorious on these radios, but hopefully that's not an issue here. But let's have a look at this. What I'm going to do first is I'm going to check the IF alignment at 10.7 megahertz, and then I'm going to check the RF alignment. So let me set it up for the IF alignment. And this is how I'm going to set it up. I'm going to send a 10.7 megahertz signal. The amplitude will be, I'll leave it at 10 millivolts RMS. I'm not sure how much I'll need. I'll show you in a second why it needs to be fairly high. Modulation. I'm going to give it a FM modulation, and I'm going to give it a deviation of 25 kilohertz and a tone of 1 kilohertz. I'm going to send it out. And the reason I've got modulation on here is because I want to make sure that I'm getting the signal coming through. I want to make sure that I can hear it first, and then I'll start doing the adjustments. Now, where am I going to send the signal to? I'm going to do this the way that I normally do it, which is the simplest way, and that is to lightly couple the signal to the ECC85 tube. And this has got a very good way of doing that. You can actually connect the signal to the shield, but to do that, you've got to remove the shield or disconnect the shield from the from ground, which is the casing. So there are two screws here. The shield comes off fairly easily. Just remove these two screws. You see, if you're going to connect the signal between the shield and ground, and obviously if this shield is screwed to the aluminium enclosure, it's effectively grounded, so you won't be getting any signal. And the way to get the signal to be heard is to literally disconnect it from the shield. I'm going to put this little pad here just to make sure that it does not short. So that should be electrically disconnected from the enclosure, from the ground. So this shield now is around the tube. So if I now take my signal from a signal generator and I connect this to ground, let me just connect it anywhere on this enclosure, and this to here, I should be able to induce it or sort of radiate it into the tube at 10.7 megahertz. And because that is the IF frequency, I should be able to hear it. Now, the way to hear it is to just listen to it on the speaker. Now, the reason I gave that 10 millivolts RMS, very high signal, quite a strong signal, is because it is not directly electrically connected. It's being induced. But this shield is doing a very good job of inducing it, of radiating it. So I need to drop the amplitude. But let me see how much we need. Now that sounds about right. If I put the volume up, I can hear it very well. There's a little bit of hiss, which is just fine. I don't want to blast it. And because I'm hearing it, I know that the entire IF chain and detector stage is working, because it is taking the IF frequency at 10.7 megahertz and it's allowing it to go through. Now, is it going through optimally? Well, I don't really know, but I can check sort of. If I take this to here and I go like this, see, I think it's actually a little bit off. It seems to be best at 10.740. If I go the other way, it goes down. So I do have a little bit of an alignment to do. And this is not with a meter or anything, this is just by ear. I can hear it, I can hear the signal strongest at about there. And then it starts deteriorating, but I want it perfectly aligned to 10.7. So that's what I'm going to do next. And from the instructions, which are a little bit vague, they tell us where to align this. See, this is the section that pertains to the FM IF alignment, and they tell us where to put it through 100k resistor to point A. I don't do that. I'm doing it my way. I'm inducing it into the ECC85, and they do tell us they've got the discriminator filter. That is the last one, and they say that you adjust A, then you move on to filter 2 and you adjust, well, actually filter 2 is E and F, and then C and D and G and H, and then you go back to the discriminator filter and you balance the diodes with B. Again, if you want to see the sort of theory, the big theory behind this, go to the Back to Basics series that I've done, and there is a section that explains all this in great detail. But I'm sure a lot of you will know what this is all about, so I'm not going to go through the full theory again. But as I said, you can always go to the Back to Basics series and find out exactly what I'm talking about. Now, this is what we see describing these IF transformers. There's A on the underside. That's why it's a dashed line, a dotted line. A is on the underside. B, C at the top, D underneath, E at the top, F underneath. And the one we're not supposed to touch in the first instance is B. So I'm going to adjust the last IF transformer closest to the EABC80 on the underside, then these two, then those two. And now G and H is a bit of a strange one, because they tell us there's the filter 1, G and H. That's the one that's inside the IF can, and they show us here where it is. There's H, there's G. Now on the actual can, I can get to H, but G is hidden behind the panel that holds it up. So I hope I don't have to touch that, because I don't want to remove this just to adjust one point. Usually these two are interrelated, so you can test it to see if it makes any difference, and if it doesn't, you leave both of them alone. This is really the rule, if you want to call it that, with any of these alignments. If you make a small change and you don't find anything altering, hey, leave it alone. Most of the time it's fine, especially if you're receiving FM. And as I said, my problem here is not so much with the IF transformers, because I can hear it coming through. My problem seems to be more with the RF stage, which has got to do with these guys over here. You know, MN, KL, X. These guys are the ones that align the RF front end, both the oscillator and the antenna circuit. These are the ones that are probably going to give me perhaps a little bit of a headache, but we'll find out soon enough. Let me start the alignment, and the way I'm going to detect if I'm optimizing this is I'm going to measure the voltage across the discriminator capacitor. Now, where is that? Well, the discriminator capacitor is here on the EABC80 between pin 2 and 7 of the EABC80. That's where the detector is, or discriminator, and there's that capacitor there. It's an electrolytic, 5 microfarads. The positive is connected to ground, and the negative is an indication of the strength of the signal coming through. Now, when you're aligning the IF, you want to measure the strength of that IF signal coming through. You want to optimize it to a maximum on all the adjustments except that last one, the one that's B. That is to balance these diodes, and we'll get to that later. And again, as I've said many times, go to back to basics. All the theory is described in quite a lot of detail there. But I'm going to put a DC voltmeter across here. The voltage I'm going to get up here is a negative voltage. The more negative, the more clean or open the sluice gates are. The path is for that IF signal coming through. It's an IF carrier at 10.7 megahertz. It doesn't need to have a tone. At that point, you know it's coming through. You don't need to modulate it. You're just measuring the amplitude of that carrier across this 5 microfarad capacitor. And that's on the underside. I'm going to put my meter there, and I'm going to make all the adjustments and see if we get any improvement. Maybe we don't. Let's see. Right, I've got everything set up. I've got the signal coming in. It's got a tone on, and I can hear it. Hear that? Right, but I'm going to disconnect the modulation. So now we've only got the carrier. And I connected the multimeter leads across that discriminator cap. The black goes to ground, the red goes to the capacitor. And I've got the multimeter on the 10 volt range. I've got it on minus DC because this is a negative voltage. And as you can see, we're getting a pretty easily discernible voltage on there. In fact, I can decrease the amplitude of the signal. If I decrease the amplitude to, at the moment it's on 4 millivolts, it drops. 3 millivolts, it drops. I'm going to leave it right there because it's right in the middle. And now I'm going to start with the furthermost IF transformer, and I'll be doing the bottom one. Let's see what happens. Oh, there's a peak. I've got a bit out of it. There's my peak. Now I'm going to go to the underside of that and do exactly the same. Try and peak it. Nope. Well, that seemed to be pretty much peaked. Anything I do is making it weaken, so that's a peak. I go to the middle IF transformer underside. No. No, that was peaked. Perfect. Now the top side. Whoa, somebody played with this. Let me decrease the amplitude again. That is now at 2 millivolts. Maybe it's a little bit too strong. We'll see what happens. No, that's a peak. There's my peak over there. Good. Now I'm going to go to the underside of the last IF transformer, which, if I'm not mistaken, is A. And it's just at the edge of the... No, it's pretty much peaked. Oh, something happened. I touched something, did I? Make this slightly weaker. I don't want to send this through the attenuator necessarily, but I think that's about as far as it'll go. Yeah, it is peaked. Okay. Normally I like to have it more in the middle, but I'd have to send the signal generator through the attenuator. And as it is, I didn't need to do that. So I did achieve something. I did get this thing up from, what was it? Somewhere there, all the way to there. So we did increase the, we did improve the IF. And of course we know that because when I showed you the signal going in, and we were hearing the tone. It was not peaked at 10.7. It was peaked at 10.74 or so. So I believe now we've got this peaked at 10.7 megahertz. That's it. That's really the IF alignment. Now there is one more thing to do, and that is to actually check the final one to do the balancing of the diodes, which is that the B, which is on the top side of the last IF transformer. And to do that, I normally send a signal in. I put a modulated tone in, and I look for it on the scope, and I try to achieve minimum distortion on a sine wave. That's one way of doing it. It's my preferred way because it is easiest. So let me set that up. We're going to monitor the scope now as I adjust this last one, and this is the one that's supposed to, this is on the underside, balance the diode section of that EABC80. And the idea is to adjust it till we get the minimum distortion. And the best way to do that is to send a sine wave modulated on the 10.7 megahertz. And you can hear it. If I switch modulation on, we can hear it and see it. I'm going to change the dummy load manager to dummy instead of having to hear it. And we can see that is not quite a sine wave, is it? So let's see what we can do with this one here while we watch it. Well, that was easy. See that? I'm just doing that. Now, of course, if I keep going, I'm going to reduce the amplitude. That's still distorted. I think this is about as good as it's going to get. And I'm going to call that aligned. Now, of course, I could actually try tuning this out. See, if I pull it out, it gets to a point where it really just loses it. And I'm going in, and we were there. Somebody had screwed it in, and I'm just bringing it out. So that will be probably the best position for an undistorted sine wave. That, my friends, is the IF alignment done. And if you followed my videos, you know there are many ways you can do this. You can do this with a wobulator version, which is to see the curve. All that is fine and good, but this thing is pretty close to perfect. And of course, the one thing you have to do, which I have to do, is go back and repeat everything. Okay, do it once, go back, repeat everything. Make sure that you squeeze out as much gain and alignment as you can. And perhaps have another look at that sine wave. Make sure that I'm happy with the sine wave. As it is, yeah, I'm pretty happy. There's a little bit of distortion on there. But if I keep going, I'm going to reduce the gain. So it's a bit of a trade-off. I'm happy with that. FM, IF alignment, done. Now we've got to look at the RF alignment, which is where the main issue is. Okay, it's time for us to correct this RF alignment. See if we can get away with just adjusting the oscillator trimming. You know, set the oscillator at the bottom, set the oscillator at the top. Tune the front end to the middle, which is the usual thing. This is actually pretty logical if you think about it. If we look at a little graphical demonstration, let me show you what I'm talking about. You see, what we've got when we're talking about the front end alignments are two tank circuits. The tuning condenser for the FM has two sections, and one section is for the oscillator and the other section is for the actual RF filter at the front to allow certain frequencies to be amplified by the first RF amplifier. Now, I've drawn this hopefully in a way that makes sense. This red is the RF front end, the antenna circuit. And this green line here is the oscillator frequency. Now what this does, what the radio does, what that FM front section does, is it takes a signal from the antenna, it amplifies it, hopefully amplifies it optimally. So the frequency you want to listen to, let's say it's 96 megahertz. When you tune it to 96 megahertz, hopefully, if you've tuned it correctly, if you've aligned it correctly, this peak is at 96 megahertz. And then the oscillator is also tuned as you turn the tuning condenser, so that when this front end is tuned to 96 megahertz, the oscillator is tuned to 96 plus the IF frequency, 10.7. So 106.7 megahertz. 104, 105, 106, 106.7 megahertz, right? Now let's say you want to tune it to 92. Why not? So this would go down to 92, like that. You see, as you're tuning, it's doing it to both. It's moving the front end, the antenna circuit, and the oscillator, so that when it's at 92, the front end's tuned to 92. So whatever station's at 92 is getting really nicely amplified, and the oscillator's producing a oscillator frequency that is 92 plus 10.7, so 102.7, right? Now, the one thing we've got to be aware of is that the oscillator frequency does not provide a bell curve like this one. It's a fixed frequency. So if you look at it on the frequency scale, it's one frequency, boom, over there, right? A sine wave. It's not usually that clean, but ultimately, ideally, it should be just a sine wave at, in this case, 102.7 megahertz. So you'd see it as a straight line on the frequency scale. The station coming in is also sort of a straight line at the 92 megahertz. But the front end antenna circuit, the antenna amplifier, is a bell curve. Now, what happens if this thing is not well aligned? What we've got is we've got a situation that we want, which is this thing should tune from 87, in which case the oscillator should be at 97.7, all right, all the way to 100 megahertz. So all the way to there, in which case the oscillator should be at 110.7. Now, if your 10.7 is not accurate, this distance here just moves a little bit left or right. If it was 10.5, this would be at it would be at 110.5. It would still work pretty well. The important thing is that when you stretch the oscillator, when you stretch the possibility of the oscillator going from 87 all the way to 108, right? 108 over there. So your oscillator is now somewhere up here, 118.7 megahertz. And this scale here, this one here, should be at 108. Now the problem is it might not be. Okay, what we might have is something like that. What happens if we have something like that? Well, what happens then is your oscillator is producing 118.7, so it's somewhere up here. So your IF transformers are tuned to allow to create this difference, right? So that this station here is still 10.7 away from that, okay? The problem is your antenna circuit is now no longer peaked at that frequency. So you will get that station at 108, but see where it is down here? It's basically attenuated. It's not really peaked. So what we're going to try and do is bring it back to normal. We're going to try and make it tune from 87 to 100, and we've got to make sure that this antenna circuit is aligned, peaked. Okay, now what I normally do is I try and adjust the oscillator first, and then I'll play with the peaking of the antenna circuit. So I'm going to try and shift the oscillator so that it shows 87 at the bottom and 100 at the top. In fact, I'm going to be a little bit naughty. I'm going to make this 102 at the top because I want to get my station at 101.6. Maybe I shouldn't do that. Maybe I should just do it by the book. Let me align this to 87 up to 100. See that it actually fits nicely on the dial and reflects nicely on the dial. The frequency that we're getting shows on the dial, or rather, the frequency on the dial is the one we are tuning through the system. And then I might stretch it a bit to try and pick up my station at 101.6. So let's get cracking. Now, how do we do this? Well, they do give us a few clues here, but they're not very clear, especially this one is not as clear as some of them that I've seen before. It's actually a little bit vague, but they do tell us to, let's see what they say, or try to understand what they say. They do tell us to do everything by ear. Gehoor, I believe, is by ear. So they tell us to set it to 87 and adjust K. Where is K? K is that one over there. So I believe this 87, or rather I believe that K, this this coil over here is the one that's going to adjust the oscillator circuit at the bottom end of the frequency range at 87. So we want to get 87 with K, and then it says go to 100 and use I, or is it L? And that's that one there. Now I think that's from the underside. That's going to be tricky. Let's do it one step at a time. I'm going to try K and see what we get. See if we can adjust it. We sort of have to play with it a little bit and see which ones do what. I believe that K is going to move the oscillator frequency at the bottom end of the scale, and I believe that L is going to move or adjust the oscillator frequency at the top end of the scale. And then what does it say? Then it says go to the 90 megahertz and M. So M will be peaking the antenna circuit at 96, at 90, I beg your pardon, and then 99.6 with N. So you're sort of adjusting that front end, the RF filter, the antenna circuit at 90 with M and at 99.6 with N. So I'm not going to worry about these two. I'm only going to worry about these two. What is X supposed to do? I don't see X anywhere. I probably have to read this a little bit more carefully, and it's difficult since I can't really read German, but I don't know what X does. I think that might be just to play with the front end circuit or the oscillator circuit to get it to oscillate. I'm not sure. So let's do that. Let's try and adjust K at the 87. I want to see where it is and try and move that to 87 at the bottom. All right. Now K is that guy over there, and I believe I might be able to get this in there. This is sort of angled, it's not. I don't think I've got it in. I think I've got to use a thinner one. Oh, I think I've got it. Good. Now, what am I going to do? First of all, I'll switch on the radio, and I'm going to use my little signal generator. I'm going to set this guy to 87. Or actually, let me do something else. Let me see where the bottom of the scale is. I'm going to tune this right to the bottom of the scale. This thing's got no antenna and it's picking up already. I'm going to put this at the bottom of the scale, and I want to see where the signal is. And I want to see what frequency I'm picking up there. I'm going to put in a little wire here just to get a little bit of an antenna. And now if I see, this thing is on, it's sending a 1 kilohertz tone, but I want to know where it is, so I'm just going to keep, I know it's higher. Oh, see that? It's picking up. Let's see what we're doing here. I've set it there to 87, but it's picking up 92. So somebody shifted. They didn't stretch the dial. They shifted the dial. So what I need to do now is to slowly play with that alignment and bring it down, like drag it down. There really is no point me trying to do this all at once because it just won't work. So I'm going to do that. See, I want to get a good reception here, so I'm putting that antenna wire at the top. I've got it at 92. I want to bring it down, so I'm going to go to there. I can still hear it, so now I'm going to try and twist this and see which way I can drag it. No, wrong way. Oh, what's going on? Have I gone the wrong way? Yeah, I went the wrong way. Yeah. See what I'm doing? I'm just moving it slowly and aligning and then going down again. I know it's counterclockwise, so I'm going to give it another couple of twists. Yeah. Ah, it's moving nicely. I've got a station on 88, that's why it's... I think this thing only goes to, yeah, 87.5. So what I'm going to do is I'm going to put this here, tune it. It's at 87 at the moment. Sorry, that there is wrong. That's 87 down here. Now it's at 87.5. And I need to find it. Yeah, there we go. Perfect. $87.5, exactly on 87.5. Now what's that done to the top end? I really am praying that this thing did not mess up the top end. Let's have a look. Let's go to 100. I'll start at 98 and see where it is. I have no idea what I'm listening to here. Really no idea. Is this low? Let's see. Okay, let's come down from the top. I'm getting 100 at below 100. Let's go up. Let's go to 100. See where we get, what we're getting up there. I'm getting 102 at 100. You see, at 100, it's set on 100 now. I can see the dial underneath there, and it's picking up 102. So I need to adjust that bottom one. Now, how do I get to the bottom one? That's going to be a tricky one. Let's see if I can get to the underside. Is there a way to get to the underside? I think I can. I think I can, but I'm not sure. Let's see, I want to move it down. There's a hole here, and I think, oh, this is going to be fun. Let's see, I need to really get in there. There's a little hole over there, and I'm supposed to get this thing into the right hole without touching anything there. That's high voltage over there. Have I got it? Doesn't look like it. That'll be a trimmer capacitor, which means it's going to be a little bit tougher to change, to move. Trials and tribulations. Can't be that one there. It must be that one there. But no, that's too thick. I wonder if this one can get in there. Oh, I think I've got it because I touched it and it starts changing the tuning. It's doing something right, but what am I doing? I'm going to bring this down to 102. It's the wrong way. I think it's the wrong way. Yeah, I moved the wrong way. I'm going to have to do this off camera because I can't get the twisting right. Well, folks, that was probably the most frustrating RF alignment I've ever had to do. I've got it, but it's not exactly where I want it to be. It's still going to 102, and otherwise it's receiving quite well, but there's still something wrong here. And I can't for the life of me figure out if I can do something about it without actually opening this guy up. I may have to do that. I'm going to play with it, see if the reception is up to scratch, but otherwise I'm going to have to remove this thing. I'll tell you what's happening. I think the notorious trim cap issue is what's coming to play, and I think I understand why it happens. When you adjust the oscillator at the top, the coil up here is for the 87 megahertz. The trimmer, it's a trimmer capacitor at the bottom end, is for the 100 megahertz. Now, when you try and fit a drill stick, screwdriver, whatever you want to call it, into the bottom, it doesn't have a direct hole going through there. So I think what happens is maybe people put in a screwdriver or some sort of alignment tool and force it sideways, and I think it's probably losing contact or something, or it's changed the lead rest down there. So every now and then you just lose everything completely. And it's exactly what they described in some of the forums I've seen, that the reception just goes, right? Like the oscillator stops working. And then if you mess around with it a bit more, it comes back to life. That's not satisfactory. So I'm going to read some more. It's working, that's the point. And I'm getting it from 87.5, I think it is, all the way to 102. I wanted it to go to 102 because of my 101.6 station here, but I would like to do that freely. I'd like to be able to choose to do that and not be forced by that shiny little bugger to do it his way. Anyway, that's where I'm going to leave it for now because, yeah, I think I'm going to have some fun opening that up. If I do, I'll give you a peek, and then you can probably enjoy my strain from a distance. But for now, that's where I'm going to leave you. And I've got something which I hope is going to be interesting coming up that I want to experiment with on this radio. Remember, I did the shortwave fine tuning, and now I'm playing with a different type of BFO, which I'm still working on. It's nearly there, but I want to be able to do a wireless BFO to decode single sideband communications on here on the amateur bands. But anyway, enough of that. I do hope you've enjoyed that, and if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon, PayPal. Links are in the description below. So once again, thanks for watching. Bye for now, folks, and most of all, stay sane.